Alrighty, so I'm going to do so this is Algebra 2. I'm going to work out the 10.2 notes, which actually means I want to do a little bit of 10.1 before we get to that. So basically, what we're using here are some what we call fixed percent equations. So we have y is equal to some number a times 1 plus r to the t power. And so generally with these problems, these fixed percentage problems, it's you have, so like say for this one, you have a starting number and you're either growing that number or shrinking that number by a certain percentage per year, month, or whatever. So for these equations here, A is going to be your starting amount. A is your starting amount. The R is going to be your rate, which generally speaking is going to be your percentage. This is the percent symbol right here, so I'm just writing that out. And of course T stands for time. So if we go to some of these problems here that we're looking at, so in December 99 there were 5,283,000 cell phone subs and subscribers in the U.S. So, and it says the number grows. Okay, so that's the big thing. So there, and it's kind of tough to see, but there's two equations that we're using. There's a decreases over a fixed percent and increases. If it's increasing, we use a plus sign here. If we see anything that's decreasing, that plus sign will be a minus sign. So we know that since we're increasing, we're going to be using this equation, the plus r to the t. And let's go ahead and fill it on in there. So it's supposed to be an arrow. So y is equal to, so A, which is our starting amount, so starting off with 5,283,000, parentheses, we're going to put a 1 there. We're increasing, so it's plus. Now, when we put the rate in, the 35%, I'm actually going to either divide that 35 by 100 or we just move the decimal place over 2 times. All right, so make sure for all of the rates, when you plug them into the equation, you either take that percent, divide it by 100, or move that decimal place left 2 spaces. And then to the t power, so my time, I started in 99, go to 2000, that is 10 years, so we're going to raise that, all that to the 10th power. Okay? Now, the only other thing I would say to do here is add those things in the parentheses. So that's 1 plus 0.35, which would just get you 1.35 to the 10th. And then from there, you just plug that straight into a calculator, how it is, with the parentheses and all. So that's 5,283,000, parentheses 1.35, raise that to the 10th. And you would get out of that around 16222,934.7. Right there. All right. Now, I'm not going to lie, it's not really this final answer I'm more worried about. I'm more worried that you can set this up properly. So if your answer looks a little bit different, but your setup is basically all correct, I will be okay with it. Now, if it's off by like, a lot, then there's an issue there. But since this is okay, then I'm just okay with that. Now we do number 8 here. Adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen decreases by about 29%. So we're decreasing. Okay, so our percentage is decreasing. So we're going to be using the A 1 minus R to the T equation, the minus R equation there. And that would give us, okay, let's just fill it in. So A is your starting amount, starting with 400, parentheses 1, because we always have a 1, minus the rate, so that's our percentage, so 29, move it over twice, so 0.29, or divide the 29 by 100, and raise that to the, and it gives you the time in 6, so we're going to raise that to the 6th power. I'm going to do the thing in the parentheses first, so that's 400 times, 400, actually hang on, no, let's erase some stuff here. I got a little too ahead of myself there. 1 minus 0.29, just type that into your calculator. You should get 0.71 to the 6. Once again, type that into your calculator. If you need help on how to type this in, please let me know. And then you should get out around 51 milligrams. It's going to be a decimal, but I'll just go ahead and round that. So it should be around 51 milligrams. Once again, I'm more worried that you can get the setup correct, not the final answer. That's not exactly what I'm looking for, but once again, if that's off by a lot, then we'll have a little bit of an issue there. All right, so we'll start 10.2 proper here, talking about the number e. All right, now e is basically a number. It's roughly equal to about 2.718 repeating. All right, imagine pi. You know, the number pi. Pi is a decimal that keeps repeating and never ends. E is the same thing, except it's, you know, instead of 3.14, it's going to be 2.718. And basically how we get that is we take this equation right here, you know, 1 plus 1 over x to the x. It's similar to the equations we were doing up top there. And basically you just plug bigger and bigger numbers in for x. Now that asks us to do that here. We're not going to. But basically if you plug big enough numbers in for x here, you will eventually get that e number there. Okay? So from that, and actually with this, I'm going to... Okay, so I am going to kind of show you guys on a calculator here. Your calculator might look different, however, generally most calculators function this way. There is an E button on your calculator, right? It might not be like a big button, but you might have to kind of look at, you know, kind of the writing on the calculator itself. So you see this little blue to the E to the X, that tells you to do second, and then type that button, and that gets you to that e to the x. So in this instance, it's second natural log. That's what happens with a lot of calculators, is that you just do second and then natural log, you get to the e button. Now, then it's e, and you can then type in an exponent. So if it's asking us e to the second, we just do that, and we get that out there. And again, we just keep repeating that. You know, e, if it's just asking us for e, just regular e to the first. That's just 2.7, and then you got the decimal right there. So let's look at potentially graphing that equation e. All right. Now, since e, as we've talked about, is just a number, once again, I'll write it here. E is around 2.718. We can graph these pretty similarly like we've graphed our exponential equations. So, as we've done before, x, -1, 0, 1, 0, 1, 2. And this is the same as just e to the 0, which is 1. E to the 1, so we've actually figured some of these out. E to the 1 is I'm just round it to 1 decimal, about 2.7. And then e to the second, which we did, which is around I'll say about 7.4. Now, e to the -1, once again, any negative exponents, I would just go ahead and type into your calculator. So again, hit your e button, go negative, find your negative, don't hit the minus sign, it's not going to work. Hit -1, you get that answer. So about 0.4. And then type the -2 in. So, come on. E to the -2, that gets you about 0.13 or about 0.14. So about 0.14. So if we graph that, it's not going to be a perfect graph. Just do the best you can with it. So 127.7, that's right about there. 3, 4, 5, 6, 7, right about there. And then the -1, -2, that's like this. So we kind of have something that looks, once again, that is not a good graph. You guys can probably graph a little bit better than I can. So looking at this now, your domain is going to be, well, as with all the exponential functions we've worked with, domain is -infinity to infinity. Your range, once again, like the ones we've worked above, it gets closer and closer and closer to 0, but it will never touch 0. And it goes up so it goes up, so we know it's going up to positive infinity. It will never touch 0, so we do 0 to infinity, all right, with the parenthesis. The parenthesis tells us that we will never touch 0, all right? Now, these right here are basically just asking you to evaluate. Once again, just type those into your calculator. I'll do the 1 over 2 because that's kind of a bit of a weird one. So second, e to the x. 1 over 2, that's 1 divided by 2. I'm just going to do that in parentheses. So like parentheses, 1 divide 2, close parentheses. and then you should get something like that. All right, so that's generally kind of how I would type that in to your calculator there. All right, so now we're going and, got a few simplifying expressions that we're going to work up through here. Remember, e to the second times e to the fourth, same basis. You just add those exponents, so that's the same as e to the sixth. So again, because 2 plus 4 gets you 6. E to the third times e to the seventh, that'll get you e to the 10th because you're adding 3 and 7. When we start to do fractions here, that's dividing, but usually what I like to do, 4 e's on top, 2 e's on bottom, cross off, cross off, cross off, cross off. We're left with 2 e's on the top. So that is e to the second on the top of the fraction. And then the 4 and the 16, we just find a number that divides both of those. That is 4. So I'm left with 1 on the top, and then 16 divided by 4 is a 4 on the bottom. Okay? Now with this one, 6 and 18, find a number that divides both of those. That's 1 over, and then 18 divided by 18 is 6, so that's 3. And then e to the 3 is 3 e's on top, 7 e's on bottom. Cross 3 off, 7, excuse me. 5, 6, 7. Cross 3 off on the bottom. I still have 4 e's. This e's not attached. I crossed more than I should have. I have 4 e's on the tops, or on the bottom, so that's 1 over e to the fourth. Okay? So that's simplifying with e, or simplifying some expressions with e. Now we move on to the last kind of formula. We started with the fixed percentage formula. Now we're going to talk about the continuously compounded formula. Now, I just want to clarify. The only time that you use this formula is if you see the words compounded continuously. All right? If you see compounded annually, compounded monthly, compounded quarterly, that still does not allow you to use this formula. It has to say compounded continuously. So, but a lot of the stuff, but it's pretty similar to the equation we used before. P is your starting amount, R is your rate. You still have to, that's your percentage divided by 100. And then T is your time, all right? So this is P times E to the R times T. So we'll kind of work out how to do that. So suppose you invest, about $1,050, annual interest rate of 5.5%, compounded continuously. How much money will you have in the account after 5 years? So, set up our formula here. Final amount, which is what we're trying to find. Starting amount, P, that's the 1,050. E stays E because that's a constant number. And then raise that to the R times T. Now remember, take that 5.5. Move that decimal place over 2 times. That's 0.055. So e to the 0.055 power times, and in that power, we're also going to put the time, which is 5 years. Now, what I would do here is take that 0.055 and multiply it to the 5. You don't exactly have to, but I just like making this one number. It should be 5e to the, and then if you multiply that, you should get 0.275. And then from there, type that number in. So that's 50 seconds e, and then raise that to the 0.275. Click enter, and you have your final answer right there, 1,382.36. Okay, so I erased this stuff. If you need to go back and get that, just go ahead and pause the video, rewind. I want to get this, I only have a little bit of time left. I want to get this last one finished. So, invest $13,000 compounded continuously. See those words you use in the, what I call the PERT formula. So, P, E to the RT. Your P is 1,300. E always stays the same. The R is your rate. That is your percentage. Move the decimal place over 2 times, so that's 0.043, and then next to that 0.043, write your time. That is 3, and then I would multiply the 0.043 times 3, get 1,300 e to the 0.129. And then from there, just type that into your calculator, and you have your answer.